Ever wondered what quantum computing is? Well, let's dive into this fascinating world. Quantum computing is a revolutionary approach to processing information. Unlike traditional computing that uses bits, quantum computing employs the power of atoms and molecules to perform memory and processing tasks. These atomic and molecular entities are known as quantum bits, or simply qubits. Imagine it as a new frontier in computation, a place where the laws of quantum mechanics come into play. These laws allow qubits to exist in multiple states at once, giving quantum computing its unique advantage. It's like having a superpowered computer that can process vast amounts of information simultaneously, in ways that our current computers can only dream of. So to sum it up, quantum computing is not just a new piece of tech jargon, it's a paradigm shift in how we compute, using the principles of quantum mechanics to process information in ways that classical computers cannot. Now you might be thinking, what on earth is a qubit? Well, let's dive right into it. You see, in the world of quantum computing, a qubit or quantum bit is the fundamental unit of quantum information. It's a little like the bits we're familiar with in classical computing, but with a quantum twist. Imagine a globe. Now, in classical computing, a bit can be at either the north or south pole, representing a 0 or a 1. It's a binary system, a yes or no, an on or off, a black or white. There's nothing in between, but when we step into the quantum realm, things get a little more interesting. A qubit, you see, can be anywhere on the globe. It can be at the North Pole, sure, or the South Pole, but it can also be anywhere in between. It could be on the equator or somewhere in the tropics or at the Arctic Circle. What this means is that a qubit can represent a 0, a 1, or both at the same time. Sounds mind-boggling, doesn't it? But that's the beauty of quantum mechanics. This ability of a qubit to be in multiple states at the same time is what we call superposition. It's a bit like being in two places at once. This superposition allows quantum computers to process a vast number of possibilities all at once, rather than one at a time like a classical computer. It's this superposition that gives quantum computing its immense potential. But just as a globe spins on its axis, so too does a qubit. And just like how the orientation of the globe determines the time of day, the orientation of a qubit, its quantum state, determines the outcome of a computation. So, unlike bits that are either 0 or 1, qubits can be 0, 1, or both, all thanks to a property called superposition. And it's this mind-bending property that could revolutionize the way we process information in the future. But what makes quantum computing so powerful, you may wonder? Well, let's dive into another fascinating aspect of quantum mechanics called entanglement. Think of it like this. Imagine a pair of twins who, no matter how far apart they are, can instantly feel each other's pain. It may sound like the stuff of science fiction, but in the quantum world, it's a reality. In the realm of quantum computing, this means that the state of one qubit, whether it's 0, 1, or both, can be entwined with the state of another, regardless of the distance between them. This phenomenon is known as quantum entanglement, and it's one of the key principles that give quantum computers their incredible computing power. Remember when we discussed qubits in the previous scene? Just like a coin spinning in the air can be both heads and tails at the same time, a qubit can be both 0 and 1 simultaneously. This is due to a quantum phenomenon called superposition. But when you add entanglement into the mix, things get even more interesting. With entanglement, we can link multiple qubits together, creating a network of particles that can work together to solve complex problems at a speed that's simply impossible for classical computers to match. So, the power of quantum computing comes from these two quantum phenomena, superposition and entanglement. These principles are the engines driving the quantum computing revolution. They allow us to process vast amounts of information at unprecedented speeds and could potentially change the world as we know it. So, why should we care about quantum computing? Well, the potential applications of this groundbreaking technology are vast and varied. Imagine a world where medicine is revolutionized, where drugs are personalized to your unique genetic makeup, potentially eradicating diseases and significantly reducing side effects. This could be a reality with quantum computing. Picture this. Complex mathematical problems that would take traditional computers centuries to crack could be solved in mere seconds by quantum computers. This could lead to breakthroughs in physics, engineering, and finance, to name just a few fields. And let's not forget the enhancements quantum computing could bring to artificial intelligence and machine learning. We could see machines that learn and adapt faster than ever before, making our lives easier and more efficient. However, it's not all smooth sailing. Quantum computing faces its own set of challenges. Maintaining quantum states, for instance, is incredibly difficult. These states are extremely fragile and can be easily disrupted, posing a significant hurdle to the technology's development. Then there's the cost. Building quantum computers requires highly specialized and therefore expensive materials and equipment. This could limit their accessibility and slow down their widespread adoption. Quantum computing, while still in its infancy, holds the promise to revolutionize many aspects of our lives, but like any new technology, it also presents its own set of challenges.